In this video, we will learn about atomic mass. After the successful establishment of Dalton's atomic theory, an important question that arose was, what is the relationship between the actual masses of atoms of different elements? The problem was not to know the mass of a single atom of an element, but the actual question was how heavy an atom of a particular element is in comparison with an atom of another element. Choose as the standard. So we want to know the relative atomic mass, basically how highly weighted one atom is in compared to other. So atomic mass unit, initially hydrogen being the lightest atom was chosen as the standard, and it was the arbitrarily assigned an atomic mass of unity, means its atomic mass is 1 unity, or atomic mass unit is 1 only. The masses of other atoms were assigned relative to hydrogen atom only. According to this scale, atomic mass of an element is that number which shows how heavy of an element is as compared to the mass of an atom of hydrogen, which is taken to be as unity. So atomic mass of an element is simply mass of one atom of that particular element divided by the mass of one atom of hydrogen. In the beginning of 20th century, oxygen atom was chosen as the standard because oxygen combines with most of the elements found in nature. The mass of an atom of oxygen was taken to be 16.00, and 1/16th the mass of an atom of oxygen was taken as the atomic mass unit, which is AMU. But these standards ran into difficulty due to the presence of isotope. So what do we mean by isotope? Isotopes basically when an element exists in multiple form, means oxygen has the atomic mass 16, but there is one another oxygen which exists whose atomic mass is 18. So there are two forms of oxygen present. They have the same atomic number, but the atomic mass is different. So one oxygen possesses 16 unified or 16 AMU atomic mass, whereas the other oxygen possesses 18 unified or 18 AMU mass. So this posed the problem. So in 1961, IUPAC adopted unified atomic mass unit U as the unit of atomic mass. Carbon 12, isotope of carbon, has been chosen as the reference, and its atom is assigned a mass of exactly 12.00. The unified atomic mass unit U is equal to 1/12 the mass of carbon 12 atom. One atomic mass unit is simply mass of a carbon 12 atom divided by 12. The absolute mass of carbon 12 is determined to be 1.99 into 10 raised to power minus 23 gram. Therefore, one atomic mass unit is simply equal to 1.99 into 10 raised to power minus 23 gram divided by 12, and the finally which is equal to 1.66 into 10 raised to power minus 24 gram. Then we have relative atomic mass. Relative atomic mass is simply the average mass of the atom of an element as compared to 1/12 the mass of a carbon 12 atom. So relative atomic mass of an element is simply average mass of one atom of the element divided by 1/12 the mass of one atom of carbon 12. The word average in the above definition is used because most of the elements as they occur in nature consist of isotopes, and therefore all the atoms of the same element do not have the same mass. The relative atomic mass of some common elements are given in table. Relative atomic masses of some elements. Here hydrogen, its symbol is H, and its exact value is 1.00 at, but commonly used value is 1.0, obviously because solving numerical problems and use in general discussion so that we can easily calculate the values. Then for carbon, its exact value is 12, and we also use 12. For nitrogen is 14.007, but we will use 16. Then finally for oxygen we will use 16, for silicon 28, for phosphorus 31, for sulfur 32, and then for chlorine we will use 35.5, sodium is 23, copper is 63.5, and silver is 108, and then finally gold is 197.0. Gram atomic mass. Now what do we mean by gram atomic mass? So the atomic mass of an element when expressed in gram is called as its atomic mass, which is gram atomic mass. Now for example, atomic mass of oxygen is 16U simple. Similarly, its gram atomic mass is 16 gram. Just we need to change the unit. We will change U with G. Molecular mass. Relative molecular mass, or simply called molecular mass of a substance, is the mass of one molecule of a substance as compared to 1/12 mass of an atom of carbon 12 It was formerly called molecular weight. Now we are seeing it molecular mass. Now how we are going to calculate the molecular mass? So molecular mass of a compound is simply equal to the atomic masses of all the atoms present in that molecule of a compound. Therefore, molecular mass of a compound is obtained by multiplying atomic mass of each element by the number of its atom present in the molecule and finally adding them together. So suppose we have a molecule which is hydrogen or H2 gas. Here two atoms of hydrogen are there. So what we are going to do is we will multiply 2 with the atomic mass of that hydrogen. Another example could be we have CO2, which is carbon dioxide gas. In that we have 1 carbon and 2 oxygen. So what we are going to do is we will write the mass of carbon, which is 12. Then we will add 2 oxygen atom mass. So we will multiply 2 with the oxygen atomic mass, which is 16. So we will see 12 plus 32, which is finally 44. Now let us calculate the molecular mass of some of the compounds or molecules. The first one is our H2O, which is water. Here the molecular mass is going to be 2 into atomic mass of hydrogen. Then we will add plus 1 into atomic mass of oxygen. Why we are putting 2 here? Because here 2 hydrogen atoms are there. So we will simply write 2 into 1 plus 1 into 16, which is equal to 80. Here molecular mass of SO2 now. It has 1 sulfur and 2 oxygen. So atomic mass of 1 sulfur into 1 plus atomic mass of 1 oxygen into 2, because 2 oxygen atoms are there. So finally we will get 64. Then here what we are going to observe is 2 hydrogen atoms are there. So we will simply write 2 into hydrogen atomic mass. 1 sulfate is there and 4 oxygen is there. 1 sulfate and then 4 oxygen are there. And finally we will get 90. In C6H12O6 we have 6 carbon. So we will write 6. Then we will have 12 hydrogen. So 12 into atomic mass of H. Then we will have 6 oxygen. So 6 into atomic mass of O. And finally we will get 180. Then finally we have KMNO4. We will write 1 potassium atomic mass, 1 manganese atomic mass, and then 4 oxygen atomic mass. So we will see 1 into 39 plus 1 into 55 plus 4 into 16, which is finally equal to 158. I hope it is clear to you. Thank you.